Been meaning to add a power feed to the mill for a very, very long time, and I'm finally going to do it. I've been messing about with battery drills, various three-phase motors, stepper motors, all sorts, trying to find the perfect system, and I haven't found it. What I've settled on is this stepper motor system with a belt drive to the handle. I replaced the scale on the hand wheel with a pulley a long time ago when I was messing about with this. It's been on there ever since. So it's a direct drive. And I found this little stepper motor controller on eBay some time ago. Unfortunately, that thing isn't quite grunty enough, and it gets very, very hot running this little stepper motor. So I'm not going to be using that. I'm going to be using a stepper driver. This is the same type that I've got on the CNC mill and the lathe, and it seems to be able to generate plenty of torque. I mean, the mill, I can move the table at 4,000 millimeters a minute with one of these, and it's the same motor on the tables on the mill. So for this lash up, I've got a couple of 18 volt drill batteries powering the driver, which is 36 volts. I've got a function generator generating pulses, which is what makes it move. I've got wired up a switch for the direction and then the enable. So just to demonstrate, you can hear a bit of a clunk there when I change direction. Belt's a little bit loose, so I'm just going to have to modify this bracket. I had thought about having a rather complicated belt tensioner mechanism, but actually the mounting holes for this plate that I've made just need ovalizing, so I can slide it away, tension up the plate, and we're done. Doesn't need to be anything fancy. So I'm probably going to mount the stepper driver at the back there, so it's out the way, wires pointing down. We'll dress them all in so they're protected, and then some sort of 3D printed cowling, I should think, just to cover it up. So I'm going to keep the controls simple, something on the front here probably, again little 3D printed thing hanging off there, I should think. I need a knob for the speed, and then some buttons to do left and right, normal feed and rapid feed, something like that. I'll work out the details in a minute. These little steppers, this is a NEMA 23. Looking at similar ones online, this has got to be about 1.5 to 2 Newton meters of torque. So obviously the function generator and all the other rubbish that I had set up there is way too impractical. I need something a lot smaller, and I have got these little microcontroller boards that I made when I was doing my original DRO project. So what I'm going to do is I'm going to reuse this board. It's got a few inputs, a few outputs, and it's small enough to fit inside this box, so this will be able to contain pretty much all the electronics apart from the controls, and that should keep it nice and neat. First off, we need to sort out the belt tensioning that's going on here. That's basically it. So now I just need to elongate these 3 holes so that we can tension the belt nicely. I'm just going to eyeball this. It's not critical dimensions, I'm just making some holes into ovals. it's actually stopping on the cutout there, which is no problem, but as you can see it's pretty much covering the entire travel, so that looks good enough to me. So I drew everything up in Fusion just to get an idea of how everything was going to go together. Obviously wanted to make sure that everything's sat below the level of the table. We can see that the handle doesn't quite, but that's an existing problem. Didn't want to make a new problem. I drew up a little box around a small circuit board. Just got some switches with some keycaps that, again, 3D printed those. This is a rough model of the variable resistor used to do the speed. Connectors on the back to connect up to my little circuit board, which will be housed in the stepper driver here. So I'm going to have to do some cable management maybe underneath here and round into here. And the main thing we've got to do is make up this little bracket here to mount the stepper driver and stop any chips getting into the vents that are on this side of the box. So this is the part, relatively straightforward. Step, scallop out of it for avoiding the standoff for the motor. This is just a relief for the screw that keeps the cover on the stepper driver. And we've got a couple of mounting screws to mount it to the stepper driver, and then holes to mount it through to the sheet metal. Well, fixed in position. Now I need to spot these holes through on the sheet metal at the end. It's almost like it was designed to fit. Right, now I need to wire this thing up. Right, so all wired up. I'm going to put the lid on, keep it safe. I'm going to leave the programming header dangling out just because it's quite likely that I'll have to change something. So I've added a bracket here to hold a cable grommet with some conduit. This is the power. It's going off to a 48 volt supply. That's the stepper motor wiring, and then the control wiring, which comes under here to the back of my little board, and the controls. Let's see it in action. So we've got a few controls. We've got stop, start, rapid and direction on this little toggle switch, and the adjustable speed on this one. So to start, I'll go the other direction. So the rapid button basically just jumps right to the fastest speed and ignores the speed adjustment. There is some acceleration in there because without that the belt just jumps because of the abrupt change in speed, but with the acceleration in it works absolutely fine. Only thing I think I'll change is this slowest speed there possibly isn't quite slow enough, so I will put in a little bit of a lower speed on that. Here's the thing in action. I recently got a new vise and it needed the bottom skimming because it wasn't flat for some reason. Mounted the vise to the mill and skimmed it. And obviously, being quite a long part, having the power feed was really useful. Definitely a quality of life improvement. So that's my power feed. It was well worth doing, and I wish I'd done it so much sooner. It now makes me want to put a power feed on the Z-axis on the mill, so that's less of a workout, I suppose. I hope you enjoyed that, and thanks for watching.